Probability, concept 23. So let's look at some of these questions. So we have 12 black and white photos. We have 10 color photos all in a box. Ethel reaches in and grabs one photo, then another. What's the probability that they're both color photos? So when she grabs the first photo, there are a total of 10 to choose from of the color ones out of a total of 12 plus 10 or 22. But then she grabs another one. So we need to multiply by the probability that the second one is color. Well, now there's only 9 color photos left, and there are only 21 photos left in the box. So it changes the probability. And then if we just reduce here, we get a total probability of 15 over 77. All right, here we have the probability of rain on Saturday is 10%. Probability of rain on Sunday is 40%, and on Monday the probability is 30%. What's the probability that it does not rain on all 3 days? So if it's not going to rain, we're looking at what the difference is from 100. So the probability of not raining on Saturday is 90%. The probability of not raining on Sunday is 60%. And the probability of not raining Monday is 30%. All right, so then if we're finding the probability that it's not going to rain on all 3 days, we can just multiply those 3 together, and we would get 0.378 or 37.8%. All right, here we have a box containing 23 chocolate cookies. 10 of those are square, the rest are round. So let's just start listing what we have here. So we have 10 square chocolate cookies. We have the rest, which is 13 that are round chocolate cookies. This box also contains 17 vanilla cookies. 12 of them are round, the rest are squared. So 12 round vanilla cookies. The rest, so there'll be 5 of them, are square and vanilla. If Ethel reaches into the box to grab a square cookie, that is the condition. We know it is going to be a square cookie. So let's just cross out the round ones because we don't care about those anymore. We're assuming it's square. What is the probability that it's vanilla? So out of the ones that are left, 5 are vanilla. Out of a total of 10 plus 5 or 15. So it's a 1/3 probability. All right, on number 13, we have Ethel making either meatloaf or spaghetti. She is 60% sure she will make spaghetti. So let's go ahead and start a tree diagram. Meatloaf or spaghetti, she's 60% sure she's going to make spaghetti. That means she's 40% sure she's going to make meatloaf. If she does make spaghetti, there's an 80% chance that her neighbors will join her. So the neighbors will join. That means there's a 20% chance that the neighbors will not join. If she prepares meatloaf, there's a 30% chance that her neighbors will join. So here there's a 30% chance, which means there's a 70% chance that they will not join. What's the probability that Ethel's neighbors will not join her for dinner tonight? So we have 2 possibilities going on here. There's this possibility of not joining, and then we have this possibility that they won't join. So let's look vertically here. To find this scenario, you need to multiply the 40% times the 70%. Plus, there's also this possibility, 60% times 20%. So this scenario here would be a 28% chance. Plus, this would be a 12% chance. So in total here, we have a 40% chance that her neighbors will not join. All right, and then last one in this section, Ethel and Edith are among 10 ladies entered in a raffle for a free tea set. 2 ladies will win the prize. What is the probability that these are the 2 women that will win? So if we just look at this in terms of probability, they're going to pick 2 winners. So let's say they're picking the first winner. There are 2 different people here that we're looking for to win. So there's 2 out of a total of 10 that would be successful. And then if they pick the second winner, Now there's only 9 people left, and only one of them will be left to be chosen. So in total here we have 2 out of 90, or 1 out of 45. Okay, you could also look at this as combinations. You get the same thing. So in combinations, the total number of choices, factorial, goes on top. The size of the group, so we're picking 2 people. And then 10 minus 2 factorial. If you were to calculate the same thing, this would be 10 factorial over 2 factorial, 8 factorial. And if you look at what that comes out to, so 10 times 9 times 8 factorial, the 8 factorials cancel out. 90 divided by 2 gives you 45 different ways that 2 people could be chosen. But it's the probability they're asking for, so 1 out of 45.